come to be. So buckle up, because this is a story about a galaxy so ancient it's practically a time machine, and a black hole that's defying the laws of physics as we know them. Let's get into it. Back in 2015, GN-z11 was already a superstar in astronomy circles. Spotted by the Hubble Space Telescope, it was pegged as the most distant galaxy ever observed, with a redshift of Z=11. That's a fancy way of saying we're seeing it as it was just 400 million years after the Big Bang. Think about that. The universe was a baby, barely 3% of its current age, and yet here's this galaxy already shining bright, packed with stars and who knows what else. When James Webb came online in 2022, it turned its ridiculously powerful infrared eyes on GN-z11, and what it found has astronomers across the globe losing their minds. This isn't just about a distant galaxy anymore, it's about a cosmic mystery that's forcing us to rethink the very foundations of how the universe works. First, let's talk about GN-z11 itself. This galaxy is a fossil from the dawn of time, located about 13.4 billion light-years away. When we look at it, we are peering back to a universe that was still figuring itself out. Most galaxies from this era are small, scrappy things just starting to clump together. But GN-z11 is different. It's surprisingly bright and compact for something so old. It's like finding a fully furnished mansion in a neighborhood of mud huts. Astronomers using Webb's NIR-SPEC instrument locked in its redshift with incredible precision, confirming it's one of the earliest galaxies we've ever seen. But the real shocker came when they dug deeper into the data. There's something monstrous lurking inside GN-z11, and it's not behaving like anything we've seen before. Here's where things get wild. GN-z11 isn't just a galaxy. It's home to a supermassive black hole, one that's about 6 million times the mass of our Sun. That's already huge. But what's crazier is how fast this thing's eating the matter around it. Black holes don't glow on their own. They're invisible, cloaked by their event horizons, those infamous points of no return. But when they feed, they pull in gas and dust that spirals into a blazing hot disk called an accretion disk. This disk gets so hot, it shines brighter than entire galaxies. And that's what we call an active galactic nucleus, or AGN. The AGN in GN-z11 is screaming with light. And here's the kicker. It's devouring matter at a rate 5 times higher than the Eddington Limit allows. Okay, let's break down this Eddington Limit thing, because it's super important. Named after the astrophysicist Arthur Eddington, it's like a cosmic speed limit for how fast a black hole or a star can gobble up material. Here's the deal. When a black hole pulls in matter, the process generates intense heat and radiation. That radiation pushes back against the incoming material, like a cosmic tug-of-war. If the black hole eats too fast, the radiation gets so strong it blows the material away. Kind of like trying to pour too much water into a glass. It just spills over. The Eddington limit sets a cap on how much a black hole can consume before this pushback happens. For a black hole the size of the one in GN-z11, it should be able to swallow about the mass of the Sun every few decades. But this one? It's scoffing down the equivalent of 5 suns worth of material every year. That's not just fast, it's physically absurd, according to our current understanding of physics. So how is this even possible? Roberto Maiolino, a big name in astrophysics from the University of Cambridge, led the team that spotted this anomaly, and he called it a game changer. He said, "It's way too early in the universe to see a black hole this massive and eating this fast. We're talking about a universe that's less than 1 billion years old here. Conventional wisdom says supermassive black holes need billions of years to grow this big. They start as smaller black holes, maybe a few hundred times the Sun's mass, and slowly bulk up by gobbling gas or merging with other black holes. But GN-z11's black hole is already a giant. And it's not slowing down. It's like finding a fully grown T-Rex in a dinosaur nursery. It just doesn't add up. One theory is that the early universe was like an all-you-can-eat buffet for black holes. Picture this. Right after the Big Bang, the universe was dense with gas clouds. These clouds could collapse under their own gravity, forming stars and black holes at a breakneck pace. Maybe some of these black holes got a head start, growing massive in just a few 100 million years because there was so much raw material to feast on. Another idea is that these early black holes didn't grow slow and steady like we thought. Maybe they went through wild growth spurts, merging with other black holes or swallowing entire star clusters in chaotic cosmic pileups. Whatever happened, it's clear the early universe was a far crazier place than we imagined. But wait, there's a twist. Some scientists are starting to wonder if we've been misreading GN-z11 entirely. A team from Oxford took a closer look at the galaxy's light, specifically the chemical fingerprints it leaves behind. When you analyze the light from a galaxy, you can see what it's made of. Elements like nitrogen and oxygen are forged inside stars and scattered by supernovae, so their ratios tell you a lot about a galaxy's history. In GN-z11, the nitrogen to oxygen ratio is bonkers. It's 4 times higher than what we see in the universe today. That's not just weird, it's a cosmic red flag. It suggests something other than a supermassive black hole might be at play here. So what could it be? One possibility is that GN-z11 isn't being torn apart by a ravenous black hole, but instead going through an intense burst of star formation. Stars form from collapsing gas clouds, and in the early universe these clouds were almost pure hydrogen and helium. When massive stars explode as supernovae, they create heavier elements like nitrogen and oxygen. A weirdly high nitrogen ratio could mean GN-z11 is churning out stars at an insane rate, with supernovae going off left and right, forging elements in a cosmic frenzy. Another idea is something called a tidal disruption event. That's when a star gets too close to a black hole and gets ripped to shreds, releasing a huge burst of energy and light that could mimic the signals we're seeing. There's even a theory about runaway stellar collisions. Imagine a dense cluster of stars smashing into each other under gravity, creating heavier elements in the chaos. The Oxford team isn't ready to throw out the black hole idea entirely, but they're urging caution. They're saying, let's not jump to conclusions. The data is rich, but it's messy. And interpreting it is like trying to solve a puzzle with half the pieces missing. The high nitrogen ratio could point to a black hole, or it could be a sign of something totally new. Maybe GN-z11 is a rebel galaxy, rewriting the rules of how galaxies form in the early universe. Whatever it is, this discovery is sparking one of the hottest debates in astronomy right now. Let's zoom out for a second and talk about why the James Webb Space Telescope is such a big deal here. Launched in December 2021, Webb is like the ultimate cosmic detective. Its infrared vision lets it peer through dust and gas that block visible light, meaning it can see things Hubble never could. It's designed to look back to the universe's toddler years, when the first stars and galaxies were forming. Every time Webb points at something new, it's like opening a time capsule. And GN-z11 is one of its biggest finds yet. During an observation under a program called JADES, short for JWST Advanced Deep Extragalactic Survey, astronomers noticed something strange. GN-z11 wasn't just a faint smudge like most early galaxies, it was blazing with light and packed with surprises. One of those surprises came thanks to gravitational lensing, a cosmic trick where the light from a distant object gets bent by the gravity of a massive object, like a galaxy cluster. In this case, a cluster called Abell 2744 acted like a natural magnifying glass, making GN-z11 appear brighter and clearer. This lensing effect let Webb zoom in on details we'd never have seen otherwise. And that's when they spotted the signs of that supermassive black hole, or whatever it is, that's powering this insane activity. It's not just the black hole's size or its feeding rate that's got everyone buzzing, it's the fact that it's there at all, in a universe so young. It's like finding a skyscraper in the Stone Age. Let's talk about that black hole again, because it's just so wild. At 6 million solar masses, it's not the biggest black hole we've ever seen. But it's way bigger than it has any right to be at this point in cosmic history. For comparison, the black hole at the center of our Milky Way, Sagittarius A*, is about 4 million solar masses. And it took 13.8 billion years to get there. GN-z11's black hole is already bigger than that, and it's doing it in a fraction of the time. It's not just growing, it's feasting like there's no tomorrow, gobbling up matter at a rate that's 5 times the Eddington limit. And somehow, it's not burning itself out. Normally, a black hole eating this fast would blast away its food supply with radiation. But this one just keeps going, like a cosmic vacuum cleaner. This raises a huge question. How do supermassive black holes get so big, so fast? One idea is that they form from the direct collapse of massive gas clouds in the early universe. These clouds could skip the star phase entirely and collapse straight into black holes, thousands or even millions of times the sun's mass. Another theory is that black holes in the early universe merged like crazy. Imagine a chaotic cosmic mosh pit, where black holes keep smashing into each other, combining their masses in record time. There's also a chance that these early galaxies were just swimming in gas, giving black holes an endless buffet to gorge on. Whatever the case, our models of black hole growth are getting a serious reality check. And it's not just GN-z11. Webb is finding tons of these weird little galaxies that seem to be home to massive black holes. Astronomers are calling them little red dots because that's what they look like in Webb's images. compact red specks glowing fiercely in the early universe. If these aren't just rare freaks of nature, then we might need to rethink the whole story of cosmic evolution. Did black holes form first, and then build galaxies around them? Or did galaxies form and then somehow spawn these monster black holes? The old idea was that galaxies come first, and black holes grow slowly inside them. But GN-z11 and its cousins are hinting at a much wilder story. Maybe the early universe was a chaotic mess of black holes and stars forming in tandem, driving each other's growth in ways we don't fully understand. The data from Webb is also giving us clues about the environment of the early universe. GN-z11 isn't floating alone out there. It's part of a dense region of space where galaxies were starting to cluster together.